So we know that authentication means the proving of identity for a user, a device, or a software component. But what are the ways that that can be proven? One way is standard. We've all done this probably for a very long time, using usernames and passwords. The problem with that is they both fall into the same authentication category. They're both something you know, so they can be guessed. It doesn't require a potential attacker to possess something to authenticate. All they have to do is try to guess something that you know. And we all know that common passwords are easy to guess. Still to date, some of the most common passwords in use include things like 123456, or ABC123, or someone's dog's name, or a variation of the word password. That's all standard stuff. It doesn't take much, really, to crack passwords just by simple guessing. But the other thing to think about is that we also want to use different passwords for every resource that we access. I know it's tempting to not do that because it's very inconvenient. Everyone wants to just use the same password that they enter when they access different websites, different apps, email, and so on. It's a bad idea because if that password is compromised, obviously, so is everything that you ever touched with it. So instead, what we can do is make sure that we use unique sets of credentials, unique passwords at least, and complex passwords for everything that we access. But then you might scratch your head and say, well, wait a second, that's complicated. How am I going to remember that? Well, what you don't want to do is store that in a text file, because if that text file is somehow compromised, there's all your credentials. Instead, you could use a password manager. There are plenty of password manager apps out there for smartphones, for laptops, for tablets, you name it. Examples include things like LastPass, or you might use a cloud-based type of key vault to store things like passphrases used by cloud services, or you might even use something built into the operating system. So what we're going to take a look at, for example, is the Windows 10 Credential Manager. Now, other third-party password managers like LastPass require you to store your credentials in the LastPass vault, which is secured with a master key. You can't forget that master key, otherwise you can't get to anything in that vault. However, in the Windows 10 Credential Manager, it's protected by your user account. That means that if your user account in Windows gets compromised, so do all of your credentials stored in the Credential Manager. But nonetheless, it's still a viable option if you have multi-factor authentication used with your Windows account along with a complex password. So let's go ahead and take a look at the Windows 10 Credential Manager for just a second. So here in Windows 10, I'm just going to go ahead and go into my Start menu, and I'm going to type in Credential. And sure enough, it pops up with Credential Manager. So I'm going to go ahead and click on that. Here in the Windows 10 Credential Manager, we have web credentials. So naturally, for websites that you visit. Now, I don't have any added here, but we've all seen it before, right? You're in a web browser, you connect to a website, you log in or sign in, and it asks you if you want to remember the password. So you could do that and have it stored here, but my personal opinion is never store passwords like that in any way, shape, or form. If someone compromises your system, it's just an easy way for them to find out what your credentials are for websites. Don't even chance it. However, if you're using something like LastPass, a password manager that is designed for that purpose, and you have a very strong master key or password, then you might opt to save your credentials in it because that's what it's designed for. But at the Windows level with Credential Manager, it depends how strong your user account security is. Anyway, I'm going to go into Windows credentials. Here under Windows credentials, there's all kinds of stuff here for different types of apps, for connecting to different container repositories or container registries. And I can see the modification date and timestamps. So these are stored credentials for different apps that I have connected to within Windows. Now, the great thing about it is that I won't always be prompted to enter in the same set of credentials. I can opt for it to fill in some of the credentials for me. Now, if you're using a secured solution to store credentials, maybe that's acceptable. Or maybe organizational security policies just outright outlaw this use because of a security problem. Over the years, having traveled for work internationally, there have been times when in the evenings I've been bored and kind of hanging around in the local office center, the office with the computers in the hotel lobby. And it doesn't take very long to poke around without even installing any tools to start seeing people's credentials when they signed into their webmail or when they logged into their VPN or signed into some web service. In some cases, it's very easy to figure that out without a single tool, just knowing where to go and what to look for. So we have to think about then different authentication methods that will allow us to securely authenticate to different services. And this is one way, using some kind of a password manager or a key vault. Then there's the notion of a one-time password, otherwise referred to as OTP. This is a unique password. You could say it's a passcode or a passphrase. It gets generated and you have to use it normally within a certain period of time to authenticate. So in addition to a username and a password, depending on what you're signing into, it might generate a one-time passcode and perhaps send it to your phone via an SMS text message. So you'd have to enter in that code in addition to the username and password. So something you know and something you have, the device to receive the code on. Multi-factor authentication. Now, time-based codes, or TOTPs, means that the code is only valid for a short period of time. For instance, once you attempt to sign in with a username and password, a one-time code is generated, sent to your smartphone, and you have 30 seconds to enter it in. Or it might be longer. It depends on what you're connecting to. But that's the idea. Let's take a look at what that actually feels like when you were signing in and you have to enter in one of those codes. Okay, so what I've done is I've configured one-time passcodes, multi-factor authentication, for my Amazon Web Services account. So I'm going to go ahead and sign in to the Amazon Web Services console. Now, there are many different sites and apps that will do this. This isn't the only one. So the first thing I have to do then is specify a username I want to log in with. When I click Next, it might ask me to type in the characters that I see or select the images that have crosswalks in it, that kind of thing. So I'm going to go ahead and specify that, and I'll click Submit. Now it wants my password. So after I've entered that, I'll choose Sign In. Now it's prompting me for an MFA code. Now what I've done is I've installed the Microsoft Authenticator app on my smartphone, and when I set up this account, it provided a QR code that I scanned with that app on my phone. And it automatically added it into the Microsoft Authenticator app. So I just have to switch into my phone, go to the Authenticator app to see what that code is. And when I click Submit, as long as I've entered it within the allowable time frame, it will accept it. However, if I didn't enter it in within that allowed time frame, it would tell me it wouldn't authenticate and I'd have to use the new code that was generated in my Authenticator app. Okay, so clearly at this point, we have successfully logged in with multi-factor authentication, specifically with the time-based one-time passcode. Now, in that case, it was sent to my phone through the Authenticator app. It could have been a phone call that read the message to me or the code to me. It could have been an SMS text message. It could have been sent through an email message, many different notification methods for that. But there is another aspect of one-time passcodes called an HMAC-based one-time password or passcode. Now, if you think back to when Mike was talking about cryptography in Chapter 2, he would have introduced HMAC. HMAC is a way to encrypt a message digest or a hash for a code to ensure its authenticity. And that encryption occurs using a symmetric key. But at the end of the day, when users sign in, all they know is they have to enter in a code to continue successfully authenticating. But that's not the only way to authenticate or to prove identity, to sign into a system securely. We can also use PKI certificates. A PKI certificate is just a digital certificate issued by a trusted authority that is then issued to an individual user. Maybe it's issued to an individual device for VPN authentication, let's say, or even certificates can also be issued to software. Now, either way, we can also have that stored on a smart card. Now, a smart card is about the size of a credit card, and it can have certificates embedded within it. A certificate proves your identity. It's kind of like when your country issues a passport to you. Obviously, the government of the country would be a trusted authority that issues this passport. As long as that's not a forged document, other parties will trust that passport as proof of identity, or even a driver's license. That's kind of what a PKI certificate is, but in digital form. So this is another type of authentication. Now you might wonder, well, what does a smart card or a personal identification verification card, that's called a PIV, what does that actually look like? We've said it's about the size of a credit card, but let's do a little Google search just to get an idea of what it really looks like. Okay, so here in Google, I've done a search for PIV card, and we have a number of returned images when I click on the images link down below. So it kind of looks like a security badge card. There are variations on this. It may or may not have a picture. Usually it does have a picture with the signature. It might even have some embedded security information. You might use this card to authenticate to a building. You might simply use it when you walk into a building to show a security guard. There are even variations of this, and it's usually called a common access card, a CAC, that takes it a step further where you can have one card that authenticates you to everything. You can show a security guard. It's got a proximity capability built into it to open locked doors. You can also use it to sign into secured computer systems or the VPN when you're working away from the office. So one card that does all of that. So usually what it means is you have to have the card, that's something that you have, and you have to know a PIN or some kind of passcode to use it. That's something you know. So again, another example of multi-factor authentication. If you're used to managing network infrastructure devices or maybe Unix and Linux hosts, you're probably familiar with SSH public key authentication. This means that instead of just signing in to a network device like a network switch or a Linux host with just a username and a password, you would also have to possess a private key. The public key that's related would be stored on that device or on the Linux server. So it's important to know where the keys are stored for the Security Plus exam. You might get a question related to that in a scenario. So the public key is stored on the server, the private key is stored with you on your station, and those two keys are related. So when you do sign in, you're specifying a username and then a password, but that password is not for the user account. It's a password, you could also call it a passphrase, for your private key file. So username is required, but the user account password is not. The password or passphrase for the private key is what you'll be prompted to specify. Continuing with authentication, we have biometric as a factor. A biometric factor is something that is unique to you as an individual, whether it's a fingerprint. Now, for a long time, we've been able to use fingerprint scans for authentication on devices like laptops, on smartphones, tablets. So that is one way to authenticate. Maybe a retinal scan for the unique characteristics of the vessels or veins within the retina, or iris scans, facial recognition. This one seems to be popular these days on Apple iOS devices. So logging in simply by it recognizing the features of your face. Voice recognition is another type of biometric authentication. Vein analysis, perhaps in a leg or an arm, if that's unique to an individual, is a possible biometric factor. Gait analysis, how you move, how you walk. And that is interesting because that could also be fed into artificial intelligence, big data analytics systems like at airports to identify someone based on the way that they walk for security purposes. Now, the efficacy rates of biometric authentication are measured in different ways. There could be a false acceptance rate where it makes a mistake and, for example, defines this person's gait as being tied to an individual when it's an incorrect match. It does happen. We also have the false rejection rate and the crossover error rate. All of these are related to imperfections that might occur sometimes with biometric authentication and trying to uniquely identify a person. So there you have it. We have a number of different ways to authenticate. Using multiple authentication factors is always preferable to harden authentication.